Our next session is being hosted by Gregory and Bonsall, and it is sort of a practical tutorial on our control systems for the GBT. This will be the front line of what you see when you're actually controlling the telescope. So take it away, Amber and Brenne.
All right, so hi everyone. I will be showing you the first part, which is AstrID, how you actually interact with the telescope and how you control it. So I'm gonna go ahead and share my screen. All right, can everybody see that? Awesome.
I can, yep.
Okay, cool. So when you're controlling AstrID, what you'll do first is you'll bring it up by using the terminal, just typing AstrID and just hit enter, and then you will see a splash screen that will have a very pretty picture and a picture of the GBT that will come up for you to see. So AstrID stands for Astronomers Integrated Desktop. And again, this is how we control the GBT and how you perform all your observations. So here, what we have that pops up first is our real-time mode. So you have your work offline. So you are completely disconnected from the telescope. You can't see anything that's going on. This is great if you're working on scripts or if you're just going to check something. And then you have work online, but only monitor observations. So here you'll see the status of the telescope, but you won't be able to control the telescope. And then finally, we have work online with control of the telescope. So when you're logged into Ariel or Titania and you're about to start your observations, you will click work online with control of the telescope, and the operator will put you in the gateway so that you can control the telescope for your observations. So I'm gonna say work online, but only monitor observations right now, and then you click OK. So you can manipulate this window any way you'd like, just like any other screen. And it's really helpful when you're observing on smaller screens. It can fit your window. So what we're gonna do first is we're gonna access a project. So here we're in our Observation Management tab, and we're in the Edit tab. There's two tabs here. Edit is where you're gonna go ahead and edit all your scripts and deal with all of that. And then Run is where you will run your observations when the time comes. So here we have our project drop down. So you go ahead and you click this button and you'll see a bunch of different codes here. So typically when you're observing, you'll be in the AGBT code. That's where all of your project things will be. I'm gonna go down to the test code so that we can look at something that I've already written. So you'll go down and you'll just scroll down to where your semester observation is. So currently it's semester 21A, and you want to make sure that you click this little arrow. If you click just the name, nothing will show up. But if you click the arrow, all the sub-projects will show up. So here I'm going to TGBT 21A 504, and that was my project code. And when you have an observation, you'll be given a project code, and that's where you'll store your information. So you can either type in your project code or use that kind of drop-down menu way to do so. So here in this little area, we have our scheduling blocks. So your scheduling block is how you interact with the telescope and tell it the configuration, what source you want to track, and all of that. So here I have a couple of different scheduling blocks, and I'll go ahead and click this scheduling block. So here we have our editor. This is where you can type your scheduling block. You can edit it from there, or you can type it in a separate text file and import that into AstrID. I always like to type it here just because if something goes wrong, then I can look at it easier and see what's going on, so I don't have to find another file. But you do have that option if you would like it. And then here you can see kind of a basic scheduling block. Your project friends will go over more specific scheduling blocks with you as the day goes on, but this is a pretty simple OH frequency stitching, single pointing scheduling block. So our scheduling blocks are written in kind of Python code. So you can see here, you've got your comments, and it's always good to comment in your scheduling block just so you know what's going on. Or so if somebody else needs to help you with fixing something, you can see what's going on. So next, we'll go ahead and we'll look at our validation output. So when you write your scheduling block, you'll see here we have a green button, but what I'm going to do is I'm going to go ahead and validate my scheduling block. So by validating my scheduling block, I am looking for the script at the script for syntax. So it's important to know that your script is syntactically correct and that it will run. It doesn't know your scientific goals though. If you have specific questions, you should ask your project friend. This is just telling you whether the telescope can run what you've submitted. And the changes don't take effect until you submit this. So you'll see a lot of times people will just validate and then don't save, and then your changes aren't saved. So you want to always make sure that you click Save to Database. And the nice thing is, if you saved a database, it's going to validate for you already. So you can just click Save to Database. And then you will enter a name for your scheduling block and click OK. So when you're in offline mode writing your scripts, you can validate. I always recommend that you validate in online mode without control of the telescope, because then you actually know what devices are bad. When you're in offline mode, it's operating like the telescope is in perfect health, nothing's wrong. But when you are in online mode, it can tell you which devices are bad, and that gives you a good idea of going in for your observation. So this light green is validated, but say I change my scheduling block. So you'll see here, I haven't validated yet. So this little stoplight is yellow. So that means it's changed, but not validated. I go to validate my script. That shouldn't be wrong, but let me see. And if it's wrong, what it will do is it will give you red, and then you'll know that your script is incorrect. So let me see if I can edit this so that's not correct. Here we go. So I'll just do that. All right, here we go. So here something's gone wrong, and you can see that by this red stoplight. It will give you traceback information so that you know what's going wrong with your script. So here it's saying the name SLE is not defined because I misspelled slew. So I go in and I fix that, validate, and everything's good. So that's a good way to check if your script is going to run or not. So I'm going to save to database. We have a button here, delete to database. Be really careful with this button. This will completely remove the script. And in these, in AstrID, everything's kind of open. So if you say are copying a script from another user and you accidentally delete that script, it's gone. So that can really impact other observers. So making sure that you're never really doing that. You can import from file. So then again, that's another way of using a scheduling block. We also have an exec file command that does the same thing. And then we have the export to file if you need to export your scheduling block to a different file. So those are kind of all of the main things on this edit tab. So down here, you can see here on this observation management log, because we're in online mode, we're seeing what's going on with the telescope right now. So it's giving you information about what's in the scheduling block. So it's saying it's in track subscan 1 of 1. So they're doing a track command. And then it's good to be watching this just so you sort of know what the telescope is doing while you're observing. If you have any print statements in your scheduling block, those will show up there too, or they'll pop up on a screen. So say you're observing a pulsar and you get the reminder to check the bandpass levels after you bounce. It'll pop up on the screen and you'll say yes or no, and it will also pop up down here. And then you run your script in the Run tab. So we'll move to the Run tab now that you've sort of seen what this observation management page is doing. So if you go to the Run tab, you will notice that you have your project code. So again, you want that to be your project code, your session number. So if it's your first session, it'll be 01, but this will increment for you if needed. You will drop down and choose your observer name. I would recommend going ahead and typing your name if it's anywhere past the letter B. We have quite a few observers, and so it's a lot easier to just type. So there you go. You can see I've put my name in, and then you will always have an operator on duty, and you will need to put in the operator's name. Amber will talk to you about talk and draw, and that's how you'll know who the operator is. So I think it might be Aaron today, but I'm not 100% sure, but you would know. So you choose the operator that's on call at the moment. So down here, you can see your available scheduling blocks that you have in your code. So you see the scheduling block and when it was last modified. A quick fun tip is if you've edited your scheduling block, it doesn't automatically update in here. If you go back to the run, I would just go ahead and click here and then click here and it will update. So making sure that you click out so that it can update, but you will see when it was last modified. So that gives you a clue if it was updated when you wanted that. So if I was to select a script and hit submit, you would see it appear in the session history. So that's showing you all of the scripts that have been run in your project. And you can also queue up scripts. So if you say you have a FluxCal and then a pulsar observation, you can queue them up directly one after each other. And it's always good to sort of separate some commands into different scripts. So that way, if something goes wrong, you only have to troubleshoot one script rather than editing a whole huge script. But that depends sort of on your preference for that. So next, what we will look at is the observation state. So this tells you sort of what your scheduling block is doing. So right now, the scheduling block that's currently running is executing, the GBT is running, and the GBT status is error. So don't worry if you see error or warning in the GBT status over here. If you're logged into a VNC, these will be colored. But the GBT status is pretty much always in error or warning. It's something to do with one of the receivers or a manager. If you're really concerned about it, you can talk to the operator and they'll be able to tell you what is going on, or you can look at the messages tab in the status window of Clio, which Amber will show you. You have your queue control. So if you need to halt your queue, say something you've mixed up scheduling blocks or something's going wrong, you can halt your queue. And then down here, you have your observation control. So you have a couple of different options there. Pause is going to go ahead and pause the scheduling block, the execution of that scheduling block, when the next line of code is encountered. So it's not very helpful, say, if you're doing a single track command observation, because that will be a long line of code, a single line of code that runs for a long time, and it's going to pause after that. But it can be helpful if you have multiple lines. Stop stops the scan at the end of the next integration time, and then abort is kind of used if the operator messages you telling you something's going wrong with the telescope, you need to abort immediately so they can address an issue. So it immediately stops the scan. It can lead to some corrupted data, but don't worry, it's usually just the last integration. And it's usually not anything you have to worry about if you accidentally click abort rather than stop. For pulsar observers, abort and stop are basically the same thing because of such short integration times. But again, we always recommend using stop if you can. Interactive is a different option. So say you need to leave the room and you have prompts in your script, it will choose the option it thinks is best. And by best, it means safest for the telescope. But usually you want to stay in the room when you're observing or let the operator know if you have to step out for a minute. So that's all of the observation management that you really need to know about besides export log. So say you're observing and you want to make sure you have a log of everything that happened, you can go ahead and export that log to a file and save that for your records. So next we will go to data display. So I'm going to switch to a different AstrID so that you can see something there. So this data display only gives you data if you're in some kind of online mode, or you can see previous data if you're in the offline mode. You can load the scan log files. So here you can see the different scans that are viewed on the side. So here there was an auto peak focus, another auto peak focus, and then a series of off-on scans. Pulsar data cannot be viewed here in this tab, and neither can mapping data. You'll have to look at that separately, but you can see continuum, you can see focus, spectral line, oof, or pointing. So those are all the tabs up here. And what you're doing for pointing For the subtabs is it should be your initial check to make sure that the GBT is pointing accurately. It will try and fit the data to the green line. And then the red data is what you're actually seeing, what's coming in. It will automatically give you pointing corrections. And basically what you're seeing is 4 plots for Gaussian plots, and it's slewing across azimuth and elevation. These will look different based on the receiver you're using, whether it's a multi-beam receiver or not. And here we're looking at L-band, so it's a single beam. Let's see. All right, so in your pointing, you have various different options. So when you're under data display, under pointing, you can go ahead and hit tools and options, and it'll bring up your pointing options. So here you have fitting acceptance criteria. So you can either do not apply corrections, automatically accept good fits, automatically reject bad fits, automatically accept good fits, interactively accept bad fits, interactively accept good and bad fits, or accept all automatically. So it automatically goes to the second option, which is usually what you'll use. And then you also have heuristics. So you have your default, standard, relaxed, and user defined. So typically it's in standard. The default is a new part of our pointing options, where for below, I believe it's 27 gigahertz, it's in standard heuristics, and then above 27 gigahertz, it is in relaxed. So you no longer have to make sure that this is selected for high frequency observations to do your pointing. It's always good to check, but that has been changed. So then you can go to your data processing, whether you want total power or raw, X left, Y right, both. And then you can send your corrections if they don't automatically send here for your as and L. And it depends on what receiver you're using for the options that you will see in processing. So say you're using the KA band receiver, you might see total power beam switched. These will change based on the receiver that you're using, but this is L band, which a lot of you will probably be using today. So that is your pointing options. So I'm going to go ahead and click out of that. And then for your data processing, so for your focus, we'll go ahead and look at a focus scan. So here you see we ran an auto peak focus. So it does those 4 peaks, and then it does a focus as the subreflector. And that green line, again, is what you want it to look at like, and the red line that you can barely see is what you're seeing. So this was a really good focus that you're seeing there. So for an OOF, which you would also run, which will look like this screen, you'll see a picture of the telescope. It is out of focus holography, and you're looking at the dish and adjusting the actuators for any kind of large scale thermal deformations. And it's typically used at high frequency. And unfortunately, you guys, like Dave said, won't be using it because none of the receivers that we would use it for are up. But this is the tab that you will be using, and there's going to be more information about this with another lecture with Natalie. So you also have your continuum and your spectral line tab. So here you can see your beams, polarizations, phases, and frequencies. And then your spectral line tab. You won't see anything here right now, but that's also there. For the spectral line, the continuum spectral line, it does not update in real time. But if you want to see everything accurately for your spectral line, you will log into Gbt IDL and process the data through there, because you're able to look at your on-off and position switching and frequency switching there. And then what we'll do next is we'll go to our Gbt status. So once that opens up. All right, so here is a window that sort of shows you everything you need to know about what's going on with the telescope. There's a kind of better window you can use in Clio that Amber will talk about called the status window that you'll want to open. But this is if you need to do a quick check of what's going on with the telescope, you can go ahead and look here. So here you can see the observer, which is currently the operator. You have your project ID number right there, the status of the telescope, which is currently error. and then your LST. It shows you the last update, UTC date, UTC time, and MJD. So here you have your azimuth that you've commanded the telescope to go to, what it's actually at, and the error. You have your coordinate mode. Let's see, you have the Zernike models if you are going to be using that. You have your elevation commanded and actual, and all of that different information, which is always good to look at. So here you can keep going down. So here you can see what scan you're on, the duration of that scan, when that scan started, whether you are on source, how much time is remaining, what your source name is. That's always good to check, just to as a double check to make sure there was no errors in your catalog. Your velocity definition, your velocity frame. So here we're in radio and local velocity frame. And the time to set for your source, which is also really good to know, especially if you are observing down to low elevations. So here it's telling you which receiver you're using, your polarity, the cal state, your switching period, what your observation frequency, your rest frequency, center frequency, and frequency state. Again, this will all change based on your science goals. And here's some weather information that is imported in. And that's kind of everything you need to know. And here you can look at your IF paths here as well. But that's that Gbt status. Again, in Clio, there's an option to use sort of a better window that's a little bit easier to understand. And so there's that. So you also have your typical drop-down menus. So if you go to your observation management, your files. So if say you're in one of those real-time modes and you need to switch, so you finish your observations and you're switching out of being in control of the telescope, you'll go down to real-time mode and you'll be able to switch there. Or if you log on and you're in offline and you need to take control of the telescope. And then that's kind of the main thing with AstrID. Again, it's always good to double check everything in here as things are going on, especially with this observation management tab, which I'll go back to.
You have a question in the chat that says, is the pointing corrections made to the subreflector or to the main alt-as drives?
So the pointing corrections, you have for the subreflector, they will be made to the subreflector. Or it will, and I believe for the as an L, it's also made to the subreflector, but you can double check me if I'm wrong.
No, you're right.
So do we have any more questions about AstrID? Oh, now I can see the chat. All right. So AstrID is pretty straightforward. It's pretty easy to kind of navigate around by yourself. And you can always go ahead and navigate around in offline mode, kind of explore what's going on in AstrID. But I will go ahead and stop sharing so that Amber can share her screen and talk to you about Clio.
All right. Let me share screen. And Brenne and I will be I'm assuming Brenne will also be hanging out after this if you guys have any other questions about AstrID as well. I think I clicked the wrong screen. Let's see. Yes. Can you guys see that?
Yes.
Okay, thank you. So what I'm going to be talking about now is called Clio. And Clio is the controlled library for engineers and operators. So even though you guys aren't engineers or operators, it's still a useful tool, probably the most useful tool we have in the GBT. And so it's very easy to actually open it. All you do is type Clio, and then it will pull up a thing called the Clio launcher. There is also a way, so essentially this is going to be a GUI type based program where it's going to bring up a whole bunch of little windows that help you navigate the GBT. And the Clio launcher is like the main, you can launch everything from that, but you do also, and I don't know them all at this point, but like you can, I think you can type like, you can actually type out Clio and then the window you want specifically, and it will open it up, or not, because I apparently don't know what the correct command is because I never use them. But I know more advanced observers who have been using it for a while will just type in the command line the windows they want open. But for our purposes, you can click on launch, or you can click anywhere in this picture box and it will give you a drop down menu. Click this because you can actually see them all. And so you have a list of things here, and I'm going to go through some of them with you, the ones that are more important. And you can also, I'll show you how, if you want to go in and just play with things, how to do that without affecting other observations. So the first thing I'm going to show you is called the Cleo Container. And so you just go to your drop down, and what this does is, because since we're doing most things remote, and in most cases you won't be at Green Bank to do your observations, you might be on a smaller computer screen and have to deal with, you know, having a 16-inch computer screen and there's like 20 screens you might think you need to have open. So what the Clio Container does is it has its own little launch menu once you've launched it, and then you can open certain Clio GUIs inside this, and it will open it in a tab-based format, so you can actually see them all. You have them all kind of contained in one area instead of having them just all throughout your screen. There are some though that don't open in this Clio Container. Status, which is one of the main ones I'm going to show you, you don't ever want to open that in the Clio Container, mostly because it will open in it, but it will cause your computer to lag out. It's literally, Status is going to be pulling from every single GUI in the system to show you all that information in one spot. And if you open it in the container, it's going to essentially like bog your computer down. So if you click on launch, the first thing I'm going to show you actually, I guess, is Status. I'll show you the message window afterwards, but this is probably a good one to start with. And so I did that wrong. I literally just told you don't do that, and I just did it. So you should ignore everything that I just said. So yes, we're going to close that. I'm going to open it through here. And so it will take, as I said, it's a process heavy GUI, so it's going to take it a little bit to actually open. And it's just going to prove me wrong again because it's going to open quickly. But if it does take a while to open, don't worry about it being broken or anything like that. It does, like I said, take a little bit to open. And you can see the status, the progress of it trying to open down here, and the bar filling up. And if you don't want the screen there, you can double click on it and it will go away. It's still going to open. You're not going to see that little window. All right. So I'm going to move this over because I have pictures in front of it. All right, so this is the Clio status window. And so this is the main window that I suggest you always have open when you're observing. And essentially, like I said, it is pulling from 7 or 8, probably even more than that in the background, different GUIs that I'm going to show you. But it's essentially all the information, all the general information you need in one spot. So first thing you'll see here is status and state. And those will look familiar because you saw those in Brenne's AstrID talk. And so these are, again, mirroring those. This is where it's getting them from, essentially, or it's getting them from the antenna GUI. But again, it's going to show you here. And like she said, it's always going to be in an error state. I almost would say that if it's not in an error state or a warning state, then there's probably something wrong, because that's a joke. It's not there's not definitely something wrong. But so the reason you're seeing error, and in this case, you're seeing it's for the antenna, because you can see this is called the scan coordinator, or in this case, you can see all the devices. And you can see which ones are the ones causing that state. And so warning is the lowest. And so error shows up because it's the highest. But the error message that you're seeing here for the antenna is most likely relevant to some process that this observer in particular isn't using. Because so the operators have another message window open that shows every single error possible on the GBT, or that is on the GBT at that particular moment. As you'll also notice, there's a message window down here at the bottom. This is only going to show what is pertaining to the current observation. So if I will do my little, side, there it is. So that window, the window down at the bottom here is actually pulling from this app, which you don't necessarily need to open unless you really want to. And that was just asking if you, there's a sound to this, but since you're using VNC, you can't actually see sound. So this is what the operators are actually seeing. Actually, they'll also have that selected. And so, as you can see, there's a whole bunch of warnings for Mustang, which isn't on the telescope right now, so is not necessary. There's warnings for the active surface, which isn't being used. And more than likely, it is the quadrant detector here that is causing that warning. However, that's not something that, some of these errors can be very confusing as to what they are. So before I was a data analyst, I was actually one of the GBT operators. And I know that this is just it's just a string error. It's nothing that's actually causing a problem with the GBT. And the operators know which messages they should be concerned about and which ones they shouldn't. But this is why you're seeing it, is because it's claiming there's a string error, but it's not causing a problem. But you can see there's hundreds of additional errors that the operators are actually seeing that you don't. And you're welcome to open this up and take a look and see, but don't panic if you open this and see a whole bunch of faults here, because they're most likely, very few of them actually pertain to you. So we'll close that. And so, yeah, you can see it's definitely narrowed down the amount of, okay, so actually what the error message we're seeing is that it says following the prime focus motors have controller faults. There is an error currently with the prime focus, and so that's what it's telling us, but this person isn't using prime focus, so it's not a problem, but it's still showing up because it's an antenna error. So then you can also see over here, you have LST and UTC. So the current time and then, UT, those are pretty self-explanatory. And then this is also pulling from, I'm assuming you can all see my mouse. This is also pulling from the scan coordinator. And so it'll tell you your source, your scan number, what the project number you're using is, what is your switching master, which is usually going to be the DCR or Vegas, excuse me. It'll tell you what time you started your scan and the length of your scan. So there's countdown and remaining here. So to go into a little bit more detail about what this is. So this is showing you all the devices that are currently being used while you're running. And then it has a state. So you'll usually see either say running, activating, idle, or ready. And so when the operator is in the control room, what they're really looking for is they have a bigger version of this screen open, and they're looking to see that all these lights are green. So actually,
jump in. You have a question. Is there a status field that tells us if the telescope is actually in an error state that we should be worried about?
So in most cases, the operator will notice that probably before you do, but if you ever see anything down in this message window that is red or a very dark orange, then usually there's might be something wrong, and you can always ask the operator. But in most cases, they'll catch it before you do because they're used to knowing what to look for and what is problematic and what's not. But if you're ever concerned, you can always ask them and say, what does this message mean? And they'll let you know if it's something you should be worried about or not. But in most cases, they'll tell you before you start, or they'll catch it before you even start. Excuse me again. All right, what was I going to open? Oh, scan coordinator. So this is the larger version of the kind of condensed window you're seeing there. And so the operators have this open. As you can see, it's just a little bit bigger than the one you guys will see, but it's essentially the exact same screen, just they have different options. They go down here and do change receivers and all sorts of stuff. So you should never really have to open this screen, but really what the operator is looking for is that all of these are in running state when you're actually observing. When you're preparing to observe, you'll see they'll be white and they'll just stay ready or idle. And then they'll turn yellow briefly while they're preparing to activate. I'm sorry about that. And so countdown and remaining. So in the time it takes these to activate, they all have to activate they all have to activate before anything goes into running. So sometimes you'll see a countdown and it'll say like 20 seconds or something like that. And that's essentially the time it's estimated it's going to take all of your systems to go into the running state. And then remaining time is actually the time left in your scan. So in this case, this person has 2 minutes left in their, so this is where you can always see how much time is left in that scan particularly. This doesn't tell you how long your scheduling block is going to run. It's only how long the current scan is. So in this case, normally you'll see an observer name here. In this case, this is an operator run project. So it says operator because whoever the operator is running it. It tells you what type of observations you're doing, They're doing spectral line. They're using total power, no calibrator, no calibrator. They're doing a track scan. And in this case, it's 1 of 1. So if they were doing position switching, it would say on off, and then it would say like 1 of 2 or 2 of 2 or whichever. And then it tells you their rest frequency. You can see what their velocity definition is and what their frame is, or you can see your own, but that should all be in your script. But it's displayed there for you just so you can keep an eye on it and make sure it looks like what it should be. Sorry. Okay, so then down here, actually we'll go over here first. So this app is the antenna app. This is one of the ones that won't open in the Cleo container if you try to open it. But essentially this is telling you exactly where the telescope is and where it's heading to. So you can see there's indicated, which is where it currently is, and then there's commanded, which is where it's going to. So if you're slewing, you would see these numbers would obviously be different. But right now it's tracking something, so they're updating, pretty quickly, and they're pretty close to each other. It also tells you the time to set, so whatever source they're looking at would set in about 7 hours. And then the drop-down menu here. So encoder is as and L, and most people other than the operators don't really know the as and L very well of the telescope. You would probably know, J2000 better. So you're welcome to, by clicking this, it doesn't affect the operators or anybody else. This just changes it for you. So you can go ahead and change it to whatever you want it to be. And so then the next window over here is kind of a cluster of the weather app and part of the antenna app. So you can see here, this green button that says on source means that they're tracking something currently. And actually you can see there, it just stopped. And now it's going into activating. And so what has happened here now is the telescope is slewing to the next source or to the next spot it needs to go to. So it's telling you in real time what the telescope is doing. And in most times you're going to see it's going to say on source or slewing. And so here you can see the activating, there's a committed, it's holding this, but everything has gone into running now. This little kind of grayed out box is where if there's a fault or an e-stop on the physical telescope, this will turn red, and it's very rare that you're ever going to see that. That usually means somebody has pushed an e-stop on the telescope, and nobody should be on the telescope if you're observing. So the likelihood you'll ever see that on, it's not very high. And then underneath here, you'll see as LPC and LLPC. These are your correction values that Brenne was talking about. So you can check to see that they actually went in here. And the operator will also probably be looking to make sure that they've gone in, and then there doesn't appear to be a focus correction that's got put in. But that's where you can see these here. And then underneath you'll see that some of this stuff is not necessarily things you need to know, but it's good to have, have it up so the operators are looking at it too. So the model, if it should say model 5 something if you're doing spectral line, and for prime focus using the prime focus, I think it says prime focus default or something like that. So that's something the operators are changing in the background between projects, which isn't really super relevant to you, but you can see if it's, if there's a big problem, it might be because this isn't the right thing. But in most cases, again, that's not something you're going to have to worry about. Then you can see the coordinate mode you've selected. So essentially what you've put into your catalog. And then underneath here, this is our weather information. So it defaults to meters per second and Celsius. I, however, am terrible at converting things. So you can actually click on these and just change them to be whatever you want them to be. In this case, I am more familiar with miles per hour and Fahrenheit. So that just changes. I can see what the temperature is. These are just the weather stations that are present. 3 is the one, weather station 3 is the one that's at the top of the telescope. So that's the one that's going to be most relevant to you, because that's the one that's, if it causes a wind problem, which I'll explain in a bit, that's the one that's going to probably get flagged first. So then on this bar graph you're kind of seeing here, this is our wind meter. So for this receiver, they're actually using S-band. And so S-band, because the beam is so large, we don't really worry about wind or anything knocking it out. like when you have a higher frequency observation, you have a much smaller beam. And so you worry about if the wind is too high that it might jostle you around and make you not be pointed correctly. So like if you're doing K band or W band or something, you'll see a bright yellow line that will usually go down to like 10. And when you see any of these little triangles kind of going into that, that means that the wind meter has detected a wind speed of about that. And if you're doing higher frequency, you want to be concerned, you want to, maybe make sure you're checking your data because it might be affected by wind speed. So the orange and the red, you'll always see are always the same. They don't ever change. They're at 35 miles per hour and 40 miles per hour. And that's because once you hit those limits, you've now hit a telescope safety issue. So 35 miles per hour, if there's an extended gust of wind or extended wind speeds at about 35, the operator will usually give you a warning and say, hey, the wind speeds are getting unsafe. We might have to stow the telescope for high winds. And if it hits 40, they're definitely going to tell you have to stop. And what that means is that because the GBT has a feed arm sticking out over the top and stuff, we have a position called survival, which the telescope will get put in so that the wind can pass safely around the GBT and not, smash into the side or anything. And they'll also probably turn it around and stuff if they, depending on where the wind is coming from. And when that happens, they'll message you and they'll let you know. They'll be like, hey, we had high wind speeds. Let me, I'm gonna have to stow the telescope for a little bit. And then usually you can just pause your observation or you can stop or abort it. But in most cases, you can just pause it. And then once the timer has gone up, so they usually wait about 15 minutes. They have to go 15 minutes without an alarm going off. So for them, they're hearing there's actually a blaring alarm going off when it hits these wind speeds that you won't hear because again, it's a VNC. So they just have to wait 15 minutes without an alarm before they'll give you the telescope back. And you do always get the time back. If you lose 30 minutes to that, they will actually give you the operator won't give you the time back at that moment, but you will get that time back for later scheduling. Because the operator is writing everything that's happening down in their logs. And so Tony, who is our scheduler, will see this later and be like, all right, I have to give them back this much time because of weather. So as I said, this system was technically built for the operators. So for the operators, I don't really find this super useful for you guys, but I'll explain what it is. So the operators, I always like to think of as the operators care about the antenna, the observers kind of care about the sky. And since this was made for operators, this screen specifically is actually looking down on the telescope. So they're checking for like, where's the sun, where the wind. So you can see the winds are kind of coming from here. That's where the telescope is. And they're looking down on the telescope. They don't really use this tiny screen all that often. They have a whole bunch of other monitors that they're looking at that keep it, that are more visible than that little thing. The operators will probably never have this status window open. They have 4 separate screens in the control room that are 4 large monitors that have all these Clio windows spread out across them. They don't ever use this condensed one. They have every window open for all the detailed views. And it took me a while to get used to using this and not having all the windows open. So then down here, we have dynamic correction. So if you're doing the high frequency stuff, you'll see these 2 buttons will usually be green because that means that they've turned on dynamic corrections for you. So if you're doing pretty much C-band or above, these buttons should be turned on in green. And if you see that they're not and they should be, you can always tell the operator it's an extra button that they might have just forgotten to click. They do about 8 to 9 things when they're changing a project. So, it's one of those things that they're used to doing, but it could be missed, but more than likely it would not be. Not entirely sure what those are for, come to think of it. They're not the corrections. I think if there's an offset or anything like that, I think they go into there. And then down here we have, you can click on so from the messages tab, you also have devices. And essentially this is going to show you your path, the path that it's following. So from the LO, what is your center frequency set to? You're using this receiver, what you can see all the temperatures and stuff like that. You can scroll over, shows that, they're not really using anything on the converter rack right now. They're using the DCR as the switching, signal switching. And then you can see it's the master and it's doing total power right now. And then if you want to go to the IF chain, you can see what IF managers are being used. So in this case, they're using, and scrolling on this is like impossible. I think you have to click and drag. You see, so if you would actually to open one of the windows, which, whoop, I keep clicking on the wrong one, which is kind of fun to play with, but I will just show it to you quickly. There's this one that's called IF Manager. And not that this is, again, this screen I'm going to open, you clicking on it does nothing. It is literally just a visual aid for you to play with if you really want to. And so what this does is it actually shows you where everything goes. So if you're using LO1, you can click and it shows you, okay, it's going to go to here. And then if you like, let's say this said it went to DCRJ1. So we're going to actually go to, where's that at? Oop, hold on, pictures are in front of things. Let me move them over there now. So there you can see these all say J1. Is this? So you kind of gotta like, I'm trying to find the DCR first. Should be, that was in the beginning. Whoop. Sorry, as I move around really, really fast. So more than likely it's coming out of this right here and you can click on it and now you see that from there it goes all the way down to somewhere else that we can't see. Or you can, if you're just curious, in this case they're using receiver 2, which has 2 polarizations, and you can see that for this one it's coming out of the right there, the 5S, or wait, does that say 56? I think it says 56. Sorry. So the LO is coming from there, and if you want to see, you can see where each polarization is going to in the splitters, and then to the so essentially this is just something you can play with. You can go through and see where everything goes to. It's not super relevant or helpful. It's more helpful to those of us doing support and stuff like that. But again, that screen does nothing to affect any observation, so you can always play with that one. And so that's pretty much the status screen. Whoop. We're going to open, I'm moving it over just so I can, we'll open the Cleo container again and I'll do the things you can actually open in here. So like I said, you don't open the status window. The only other things you really probably need to have open, I'll go over those here in a minute, but so there's something down here called operator tools and observer tools. Operator tools, you'll see have some of the same things as the observer tools, but those are mostly the things that the operators are using. So you're gonna go to observer tools and you'll see there's 4 things here. These last 2, I don't really ever use. They can be useful to some degree, but I find that the things you're going to use most often are the scheduler and sky viewer. So scheduler and sky viewer is essentially the program you can use to track where you to decide how your observation is going to be set up and then also watch them in real time. So there's schedule mode here, which means that the telescope is it's not showing you where anything is currently. And as you scroll down, you can see you have all sorts of options. So let's say you know that you are observing later tonight. You can actually go in and change your date and time to when you're going to be observing. And then it will change and rotate the sky to be whatever time you're observing. And now you have to remember this is in UT. So we're just going to say it's that. And then you can increment it by an hour or so. So you can see it changes the sky. So if you know you're starting observing at 10, and then you want to see where your source is going to be, and I'll explain to you how to put your source in here in a minute. You can actually add hours to it to see how it's going to move and where it's going to go. You can do the same. You can also put in your right ascension or your galactic position as well, just by clicking on these. You just have to make sure that you actually tell it to accept it. If you change it and then don't click accept, nothing's going to happen. And then you again have the button now where you can just say, I want to see what it looks like right now. Okay. Oops, scrolling up. Some of this stuff will be very laggy when you're doing it too. So also you can set, actually here, I'll show you this first. So under catalog, you click on this and right now you'll see there's nothing there. So you can go to this add and select or deselect catalog. And so this will come up and you'll see these ones here are actually our default catalogs that we already have programmed into the system. And when you're writing your script, you can actually call them by name. You don't have to give them a location. The system knows where they are. So FluxCal is probably the one most people will use for calibrators. So you click on that, and as long as selected green, you click apply. And now all of the sources in that catalog have been put into your catalog here. However, because these might not include the source that you want to be looking at, you have this button here called Add User Catalog. And so it should take you to your own directory because that's what you're logged into. I believe I have a catalog in here I have a whole thing called catalogs. And so now my catalog is there, and you can change the color so that you don't, because they're always going to default to that green. But if you want to be able to see the difference, then you can click apply. If you click OK, that makes that screen go away. And as you can see, there's only the green ones here because my source is not. There it is. So now you can see that they are that it's starting to show up because it wasn't visible currently at that time, or it isn't visible right now. And so then you can actually hover over it and it will show you everything you need to know. I can't move my mouse to show you, but you'll see there's galactic latitude and longitude, your right ascension, your declination. And it also shows you over in the left corner, bottom corner, where the telescope is now. It tells you in minutes how long it's going to take the telescope to get there. And that's pretty accurate in most cases. But again, this isn't real time, so that's not actually an accurate time right at this moment because that's not where the telescope is. You could actually click real time quickly, which will show you where the telescope is now, and then go back to schedule. And whoop, but now that requires me. And this isn't accurate. I wouldn't actually do this, but just as an example. See, now it's changed to about 5 minutes to get to it. So if you were to get control right now and your source were to be right here, which it won't be because this is, several hours from now, that's how long it should take to get across there. And then if I go back to catalog, so this will stay up until you close it. And then you can always deselect catalogs if you don't want them there. You can take them out and like clean up your screen. So you can also turn off, you don't want all these labels, you can turn them off. So if you don't want the moon or the planets to show up, you can tell it what system you want to see it in default. And actually I should go back in and put that back in quick just to show. So then if you're looking for a calibrator of a specific intensity, you can actually change this to be, I always forget if it's millijanskis or janskis. I can't remember. I don't know if Brenne knows or anybody else who's on currently knows, but I always forget if it's janskis or millijanskis. So you can change this value. Whoop, that's really high. And you'll see that they should start to disappear because you're saying, okay, I don't want to see anything that has a intensity lower than 10. And so you can actually see, so if I hover over this one, up in the top of the screen, it gives you the name, it gives you the right ascension, but then that last number that's outside the parentheses should actually be the intensity. So in this case, it says 14.43 is the intensity, which is of course higher than 10. So that's why it's showing up. So if you're looking for specific intensity or something like that, you can actually find it in this as well. And then if you click on real-time mode, you'll notice now you can't change anything because this is what the telescope is like right now. So you can't actually go in and change any of the time or anything like that. And as you can see, my source has disappeared. This is still accurate. I can still change that back to 0 and make everything that's currently up appear. And so what you'll notice on this screen is that this is the opposite of that other screen that I was showing you in the status window. This is actually looking at the sky. So if you were to look up, that's what you're actually seeing. So you can see these are the azimuth from 0 to 90. The telescope will not go below 5 degrees elevation and cannot go above. We usually say don't go above 80. So what happens within this little window here, we call this the keyhole. And because of the way the telescope is tracking, it can't, in a source that's like pretty much at the zenith, it can't track fast enough to keep up with things that are going through what we call the keyhole. So I wouldn't recommend ever really, I wouldn't observe this source right here. It's very close to, it's not at 80. So you could, if you really wanted to, but I would probably suggest letting it, come down a little bit before you try to play with it. So you'll see here, this is the North Celestial Pole. And this black circle you're seeing here is actually, so the crosshairs in the circle is where the telescope is now. And what this circle is actually the path that the source is going to take. So whatever source they're observing right now, this is the path it's going to take. And you'll usually see that it's going to move from left to right across the screen. So these are the things that are rising, and these are the things that are setting. And so this is also convoluted, and I would never suggest using this to figure it out, but we have something on our telescope called a wrap. This is how the telescope spins. It has, obviously, it's not in a circle, it's in kind of like a nautilus shape. And so there's a line here that's actually kind of blurred on my screen and hard to see. And those can also indicate the ends of the wrap. So if you're observing a source and your source is going like this, oh, sorry, I guess it would be going like that. So if it's going like that, and that's the end of the wrap, the telescope can't go any further. So what it's going to do is it's going to go through an unwrapping process, and that takes 10 minutes to do. So you always want to be careful to kind of check where the telescope is at the time. And you can actually do that by, so I have to use the encoder to see that, by what's here. So the azimuth can actually, as you can see, is a minus number here. So it can go from, I think, minus 90 to positive 400 or something, I believe. Actually, I will show you how that screen works. There's one screen that I will open that I only use because I'm lazy and don't feel like figuring it out myself. The antenna screen is the only screen that shows you the actual wrap. And so this is, like I said, this is that encoder screen that you were seeing that's in the status window. But what I'm looking at is this blue line right here. So it's from minus 90 to 450. So if your source is down here, as you can see they're kind of at the end of the wrap. So if their source is going this way, they can't, and they hit this point, it essentially has to find, because like I said, it's a nautilus. So there's 2 points in the wrap that will equal the same actual azimuth and elevation, or azimuth, sorry. And so I don't remember what minus 60 is, but essentially it's going to, instead of continuing to go this way, because it can't, it's going to follow this and try to get to the other side of the wrap, and so that it's equivalent to this. And so that takes about 10 minutes to do. So usually you want to watch beforehand, and the operator usually catches it as well in the beginning of your observations, because if you're moving here and you're doing an on-off, and you're doing your first one, and then you try to move to your off position and it's over here, it's going to unwrap, and you really don't want to, have to sit there and wait 10 minutes to finish your on-off scan. So there's just something to be aware of, and we can explain, I'm sure your group leader will explain that in more detail. So yeah, so I don't really, it's hard to determine if you're hitting the wrap on these, because just because it's here doesn't necessarily mean it's hitting the wrap, because like I said, so essentially the wrap is, if you think about it, let's say it starts here and it will go around and then stop here. So there's 2 points there where it hits, and just the only way to figure it out is by whatever this azimuth number is. So if it's close to minus 90 or close to positive 450, you're near the end of the wrap, and you should probably double check on it. See, I think that's it.
We have a question. What does the red line represent?
Oh, I'm sorry. So the red line is the galactic plane. Yeah, sorry, I forgot to explain that. So yeah, that's just showing you where the galactic plane is currently. So if I go back to schedule, you'll see it should move. So that's just indicating that. All right. Oh, let's just say no, because I don't actually want to close everything. So we'll go back to this.
And that source intensity range is in Jansky's.
Okay, thank you. I always forget that. All right, so I'm sorry you're going to have to deal with my soapbox. This is my soapbox, and you're all going to hear this at least 2 more times probably. Talk and draw. As Brenne mentioned, talk and draw is the app you're going to use to talk to the operators. As a former operator, this is my soapbox because, as I explained, the operators have sound in the control room, you do not. So when I logged in just now, there was what we call a horn honk that went off in the control room. I believe the operator probably heard it, and I'm just going to let them know quickly why I logged in. Okay, so not only when I logged in, but when I typed and hit enter, that horn honk went off again. So the reason I say that this is My soapbox is, as a former operator, every time you type, every time you enter, every time you exit, that horn honk goes off. So talk and draw is used for you to communicate with the operators. You can talk to other people as well. There's this button here called create a new group, where you can create the group, and it will, I'll show you that in a second. Just put hi. So essentially this creates a group that you notice now just has me in it. And then you can edit membership and add anybody you want to that group. So the reason I'm saying this is because as an operator, at 2 o'clock in the morning, when people are deciding, let's say one person has logged on and the next observer is on, getting ready to start. So they might say, you know, they know each other. So they might be like, hey, this is Emmanuel. They like, you know, I could message and be like, hey, Emmanuel, how are you? And then he could be, you know, he'll be like, oh, I'm great. How's your observing going? Every time they do that, that is honking that horn in the control room. And the operator, who doesn't need to be paying attention to that, is going to hear that. And they work 12-hour shifts. They don't really want to listen to that continually. And it's also, I like to say, the boy who cried wolf scenario. If you keep doing that, they're not going to know, they're going to start to just tune it out because they think you're talking. So when you do actually need them, they're not going to turn around and look because they're going to assume you're having a conversation. So it's always, and actually some of them will tell you, stop doing this, create a new group and have this conversation somewhere else for the operator. Because it's their attempt, because like I said, they're sitting there for 12 hours. They're monitoring every telescope on site. That sound is used to let them know that you need them. There's also this button called get attention. That button shouldn't exist, and never ever touch that button. That button, I don't know why it's even there, but that literally all it does is honk the horn. It tells the operator nothing, no information other than that you're trying to get their attention. And you also have to remember, they are human. They do have to get up and go to the bathroom. A lot of them do actually have to eat when they're there because, you know, if you're on a night shift from 7 p.m. to 7 a.m., you have dinner at some point usually during that time. And even if you don't, you get hungry if you're awake for 12 hours in the middle of the night. Trust me, you get very hungry because you have nothing else to do but eat. So they will get up and leave the room. The bathroom isn't in the control room. So if they don't answer you right away, give them like a minute or two to respond to you, because number one, most of the operators are, actually, I see somebody's hand is up. Go ahead, Jordan.
Oh, yeah, I was just wondering, when you said create a new group, do you mean like with that button in there and talk in this interface, or do you mean we should use some other platform to communicate?
No, so within this interface, so if you create new group, which I already did, you can talk and draw. Just now you'll see the only people in this group are me and whoever I choose to add. So in this case, if I wanted to talk to Emmanuel, I would just add him and not the operator. And then in this case, then because the operator is not in this group chat here, they don't hear anything or see anything that's going on. So their alarm isn't going off every time you type. So you can type in, if you create a new group and add people to it, you can talk to them without having to worry about them, essentially the operator hearing that constant beep, 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 or honk, 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 as it actually is. I forgot what I was saying now.
Thank you.
No problem. So like I said, this button should never exist. And you do have to give them a couple minutes because like I said, they are, number one, some of them have been around for a very long time. And I know for a fact that they hunt and peck type. So they do type like that. And so it can take them, number one, a bit of time to type. If there's a problem, more than likely they're focusing on what your problem is. They'll do their best to keep you updated with what's going on, but constantly sitting there saying, what's going on, what's happening? Every time you do that, they have to stop what they're doing and respond to you. So just always give them like 2 minutes or so. If they don't respond within 2 minutes, then, then you can try calling them or something like that. But, in most cases, they're either trying to solve a problem, they've gone to the bathroom, or, they're in the middle of typing to you and they're just not typing very quickly. There are some there that are younger and, can type pretty quickly. But some of our older operators can take a bit, or they'll just, like I said, they're working on something else and they'll get to you. They just, every time you ask them a question, they have to stop and tell you what's going on. And so the other thing is when you get your start, so when your start time is, let's say your start time is at noon, you'll see the operator will take control at about noon and will probably start doing things, and you'll log in, you'll say, hi, I'm Amber, I'm here to do this, I'm on. You should be using aerial titania to observe. And the operator will start to set up for you. So now, technically, when you've put in your proposal, if you read the observers or the proposer's guide, the first 15 minutes of your observation is actually designated for the operators to do their setup. It should never take, unless there's a major problem, 15 minutes. If it was a simple just changing the receiver, I could do a full project change in 8 minutes. If it requires switching between prime focus and the Gregorian receivers, that alone takes 8 minutes. So it could take up to 10 minutes to actually change it. Actually, at one time, I could do them in under 3 minutes if I had to. But you have to understand they're trying to change. So don't sit there and say, hey, can I take control? Hey, can I start? Stuff like that. They'll let you know when you can start. And a simple way to actually tell is back here on the status window. If you ever see, when there's no one observing, if you ever see antenna is running or moving and you see that that essentially means that they're either bringing in the prime focus, they're moving the turret. That means they're actively doing something. And like I said, some of these things can take a couple minutes to do. So they might just be sitting there waiting for it to finish. But if you ever see where everything is white and antenna is like yellow, is activating, that means that they're in the middle of doing something, changing over to prepare for your observations. I would usually say if you haven't heard from them in about 6 to 8 minutes, you can message them and say, hey, is everything okay? But in most cases, they will let you know when you're ready to begin. You don't have to keep asking them when you can start. They will let you know when they've completed everything they have to do, because they have several steps they have to go through, and though they can do them pretty fast, in some cases it might take them a bit to actually complete them. The last thing I'll say about this is that because it is called talk and draw, there is a draw window. You can draw, you can do all sorts of things in it. And then you can actually send the drawing if you really want to, which I do not. I'm going to close that. My one story that I like to tell is that I have a friend who does actually bring through listen observing. Him and another observer were on. He knows that my spiel about the horn honking and that I can't stand it. I was the operator, and I look over and I hear honk, honk, honk. I'm like, what is happening? I look over and there's just H, M, Q, L. And I'm like, what? I think he's got to be just doing this to annoy me. So I said, what are you doing? He goes, open the whiteboard. And when I opened the whiteboard, they have actually, they were playing Hangman in the talk and draw window. And so he was putting in the letters into talk and draw, and then the guy was editing the Hangman in the whiteboard, which ended up being rather entertaining for me to watch. But yeah, so the whiteboard does exist. It's not super useful, but I guess you can play Hangman in it at least. All right, and so then I'm going to close this now. And so again, that horn honked when I closed that. So they heard it, and now he knows that I've left. He'll get a prompt that says I have left the conversation.
And I will just jump in and say there's 2 buttons called auto sound and auto raise. And since you're in a VNC session, go ahead and click that auto raise, and it'll bring talk and draw to the front. So you never have to hunt for it. It'll come up as soon as somebody messages.
Yeah. Like I said, I don't really know what these, I know what they do. I don't ever find them to be super useful. The other things that you probably can open that actually isn't displayed in this window. If you're doing Spectral Line, actually I guess even if you're doing pulsars now, you can pull up under backend Vegas, and you'll actually you can see the Vegas manager and the state, and you actually can see the individual states. So you'll see Vegas was in this list, but it's not, you don't see, there's 8 banks of Vegas, and you actually can't see each individual bank. So when you open this, so now you can see that right now this person is, so this is probably a bad example because Breakthrough Listen is running. Breakthrough Listen actually has its own special backend that it's running and actually turns Vegas off when it's doing it. So sorry, my fiance is trying to get the dog downstairs, and I hear him in the background. So what I actually tend to open sometimes, and this again is an operator trick, but this is actually something that you can actually open and look at, mostly because I'm a visual person. And so all these numbers along the side of the screen here are like just a line of numbers and mean nothing to me. And so I will open up, it's called Vegas Power Monitor, and it takes a second to open. But what this is going to show you is you can see there's this one that says all measure power. So you can see all 8 banks, or you can look at the individual ones. If you're using a particular one, it will show up green. So since they're not using any right now, you don't actually see any of that. But what I'm looking at is for these Vegas power for the ADC power, the power level should always be this peak should always be between -50 and +50. If it's high, Cassie did, oh, you can't actually see her, the dog just walked in. If it's 0, that means there's no power going into the system, and so you should be concerned, and you need to tell the operator if they haven't noticed. Or if it's too wide, that means that too much power is coming into the system. And then on this chart, usually because it's running, you'll see like a green and red line that's going across, and that should be about at -20. If it's like -45 or something, something's not right. But again, the operators are watching this. I just like to have the screen open too, because it's a visualization for me to see, do the power levels in Vegas look fine? So I tend to open that. You can close, close it on its own. Okay. And so that's the Vegas. And you can see all sorts of, you can see what mode you have set. You can see that they're not all in service. You can see all sorts of stuff from this window. Just want to make sure that I got all the windows here since we're just about out of time. Like I said, you can go in and play with all of these. You can open most of these. So any of them that if you try to change anything and you're not in what we call the gateway. So the gateway is something is what the operators use to give you permission to play with the telescope or have control of the telescope. I'm going to show you what it looks like. Oh, really? Okay, we're gonna. I probably got that wrong, but yep. Okay, I always forget. But I will show you what this looks like in a second. Yeah. So you can't open this because I'm not going to tell you what the password is. But the operator, I still remember it from when I was an operator. So this is actually what is giving you permission. So the operators will pick, they go by your last name. So I'll find myself, and I'm not going to give myself permission to do anything, but here's my name. So they'll click on the name. If you're observing, you should be on Ariel or Titania. I always prefer Ariel because I grew up in the generation of The Little Mermaid. So I would pick Ariel, and then they can give you access to, usually they'll give you access to these 3 things. These 3 things. They'll say allow, and then that means that you have control. Until they do that, you can't actually change anything of importance. It's unlike AstrID, it is actually like locked out otherwise. So you actually can't, there's certain things you won't be able to, unlock and play with because you don't have permission. And then one more thing. Oh, I was going to show you the, well, actually, here's the weather app quick, just so you can see what that looks like, the entirety of it. So there's a lot of stuff going on here. You can see there's that little circular thing and all the weather stations. You don't really need this open, but it does have like the dew point and wind chill and all sorts of stuff on there. It also has a lightning detector on it as well. And so I had mentioned that you do have a way to play with the telescope if it's in, but that doesn't affect the actual telescope. So as an example, real quick, I will show you, let's say they are using receiver 2.3, which is S-band. So receiver 2 gigahertz to 3 gigahertz. So this is what the screen looks like. Not that you would have any reason to go in here and do this, but if you tried to go in and unlock it, says you cannot do that. You don't have the privilege to do that. So let's say you just want to see what filters there are or something like that. So on that launch button, there is something called simulation mode. And if you click on that, it says, warning, you're turning on simulation mode. You say that's fine. And now you'll notice if I go to receiver 2.3 and I open it, it will say, it's creating a simulator. Do you want to continue? It's letting you know that this is not the actual thing. So the values are all going to be like, it's going to say not connected and 0 because nothing, there's no actual power going to it or anything. And so it's going to have default values. But now you'll notice you can click that unlock button and you can go in and select all the filters and, change things and stuff like that. But nothing is actively going to affect the real telescope at this point because it's not actually connected. The one thing, if you do that though, you want to make sure you remember to go in and actually unselect it. because it will stay selected until you unselect it. So now I'm back to, you see that button is no longer green. And therefore that means that I'm out of simulator mode.
So we do. What,
Go ahead, Bren.
what is Vegas is our question.
What is Vegas? So Vegas is our spectral line and pulsar backend. So that is what we use to essentially process your data and send it to, essentially it's coming from the telescope, goes down all these different channels and then goes into our backend where it's processed and broken down into something that is manageable for you to view in however you choose to process it, either using Gbt IDL, using the pulsar options like Presto and stuff like that. It's essentially creating the SD-FITS files that allow you to read the data and instead of it just being noise and stuff like that. So Vegas, go ahead.
Vegas stands for Versatile Gbt Astronomical Spectrometer. So
yeah.
you love acronyms.
Yeah, I tend to forget that one sometimes. That's why I was just like avoiding actually saying what it stood for. Mustang, I think, is the worst acronym because that one I just can't even remember. So Mustang is an acronym. Argus is not an acronym. Argus is the name of a mythical monster. So it's actually not an acronym. So when people type Argus in all capital letters, it annoys me. But is there any other questions about anything else in here? Like I said, you can go in and play with all these things. They won't let you do you can't do anything that would damage the telescope. So you don't really need to worry about it. But usually, I guess the last thing I'll say is that when I am observing, I will usually have status window open, the Cleo container, I will have scheduler and sky viewer, and I will usually have the talk and draw, which I'm not going to open again because I don't want to make it honk. And then the back end, Vegas backend is usually what I will have open. What will happen is you'll learn from your group leads. They'll show you how they do it. And essentially you'll eventually come upon your own way of doing things, your own, what do you want to have open? What do you want to deal with? How do you want to see things? You'll find like you'll always want your screens in a certain spot. And that's all stuff that will come with time and you'll develop your own way just from seeing a whole bunch of different people do things. So yeah, I wouldn't worry about having to have certain things open. Status and scheduler are probably the important ones, obviously in talk and draw, but you'll find your own way of having things open and visible. All right, does anybody have any questions? I am guessing not.
Laura, you can go ahead and unmute yourself.
Yeah, I'm just wondering, like how far in advance should you sign in to Talk and Draw before you take over? Is it like really annoying if you sign in 15 minutes early? Should you not do that until right at the switchover? Or?
Oh no, so that is an excellent question. I should have covered that. So according to the Observer's Guide, you should technically log in 30 minutes before you start. And when you log in, it's completely fine. Like I've already logged in hours in advance just because I like want to set everything up. And I'll log in and I just tell the operator, hey, I'm here to do this in this many hours or whatever. And they'll be like, okay, that's fine. You can log in. Just always remember to log out when you're done. You don't want to ever leave these things open when you're done with them, but you can log in early. That is completely fine. We say the standard is 30 minutes beforehand, and that's for you to get set up and stuff like that. And so it's completely fine for you to log in early. It's not going to bother the operators. They're just going to be like, okay, whatever, it's fine.
If you log in early, sometimes if a project finishes, say they're doing on-offs and they won't have enough time to do a full on-off set, they may say, okay, I'm going to give up the rest of my time to the next project. They can start 5 minutes early. So if you're logged on early, like you should be, you'll get a little bit of extra time just kind of stuck into your time.
And I guess that's also a good thing to mention is sometimes what will happen is you log in, the previous observer will be on, and they might actually say in the opposite case, hey, I need 2 minutes to finish my second on-off pair. Can I, have that extra 2 minutes? And the operators will go to you and say it's your time. You can decide if you want that. However, the operators will remember. So like, essentially, I guess I'm trying to say, don't be mean. If you give that person time, because like for 2 minutes, because like I said, it takes them several minutes to change over anyway. The operator will, unless you're not online, they will always say, yeah, do whatever the observer says or do whatever they're offering. So like if you give up like, a couple minutes early or, somebody asks, can I go over into your time a little bit? the operator will kind of like, remember that and be like, okay, well, this person, because we do have people who will be rude and be like, no, I'm sorry, you can't have that extra time. And the operators don't really like when people are rude like that. So unless it's like something like paid for time that you have to have, always try to be polite to your fellow observer. If they ask for like an extra minute or two, let them have it. I mean, you don't have to, but it's sometimes that will happen. They'll say, I need an extra minute or so. Can I, finish this set of on-off scans or something before I log off? Because they don't want to stop in the middle of a pair. So, just try to, if do what you would want them to do for you. If you were to ask for that, you would want them to not be rude about it. All right, was there any other questions? Nope. Yeah, sorry. So yeah, if they have paid time, you cannot actually give up their time. Usually this will happen if for like in my instance for radar, a lot of times radar stuff is paid for time and we can't actually give the other, physically cannot give them the time because it's been paid for and it's stuff like that. So in that case, that's not the observer's fault. They can't do anything about it. Actually, I think Will and I went through this we did the Perseverance landing where we literally couldn't give them the extra time because they had paid for it. Even though we would have liked to, it was just the nature of the business end of it. So it's not always their fault if they can't do it. But in most cases, that's not really, it doesn't happen that often. But yeah, paid time cannot actually give up their time. All right, well, if anybody has any other questions, I will stay logged in through the break. And I'm happy to ask any other questions kind of offline if you guys want. Oops, stop sharing. Ta-da!